Assalamu alaikum everyone. Hope you all are staying safe. My name is Rahmeen Gul. I'm a student of BEE12B, presently serving as an executive and external relations IEEE 6. Shahir, you can introduce yourself.
Assalamualaikum Tech Geeks. My name is Mohammad Shahir and I'm a sophomore studying electrical engineering at SEEKS. Also, as you can view on the slide, I'm an executive admin events at IEEE SEEKS. So this is the third episode of Tech Talks, which are organized to give you the learning opportunities you have been looking for. So these Tech Talks are hosted by NUS Cybersecurity Club and IEEE SEEKS. So what is NUS Cybersecurity Club? CSC NUST is a NUST-based club, and as the name implies, it is heartily dedicated to cybersecurity, which is one of the most demanding technologies in the world right now. So if you don't know the threats of the online world, if you don't know how to stay safe on the internet, if you don't have any viable source to learn this fundamental technology, or if you are or were being a victim to basic cyber attack, then NCSC is always here for you. NCSC drills workshops on weekly basis from where you can learn a lot of knowledge about this fundamental and important technology. So the motives of NCSC are to enable a secure environment, empowering people with the latest technological trends, allowing you to know the weakness of your design, setting a basic path for those who want to pursue this field. So the other major partner, which is of these tech talks, are IEEE V6. So IEEE, as most of you know, is the world's most elite student organization, and IEEE SEEKS is actually the next chapter of this global society. So IEEE is dedicated to advancing technology, innovation, and excellence, for which purpose we have held many workshops. As you can see on the left, we have held workshops about these amazing technologies in the past and will be doing in the future, inshallah. So IEEE is dedicated to promote women engineers to excel in their professional skills, and we encourage them and give them a platform so they can to promote learning and facilitate them in enhancing their technical expertise. So we have the same motto at the Global Society of IEEE: we innovate for a better tomorrow. So now, Rahmeen, you can tell about the event.
We are glad to announce that episode 3 of much anticipated Tech Talks is finally here. Today's agenda is to familiarize all of you with the fundamental concepts of MATLAB programming, highlighting its significance in research and development. It is actually the fourth generation high-level programming language and interactive environment for numerical computation, visualization, and programming. It has numerous built-in commands and math functions that help you in mathematical calculations, generating plots, and performing numerical methods. As you all know, Sir Talha Mehboob is our speaker for today's Tech Talk. He's currently in his fourth year of undergraduate study, individual with a decorated resume, presently serving as an editor and WordPress developer at AI Lounge, and he's also working as a research assistant at two of the most coveted lab in SEEKS, Tuckle and Sigma. Now, I would like Sir Talha Mehboob to share his field of vision about what MATLAB exactly is, as per his practical knowledge. Kindly, sir, please take the lead.
Okay, thank you so much. Can you please stop sharing your screen so I can actually share my screen? Yeah, thank you. Okay, so if you could actually tell me that you can see my screen. Is it visible to you guys?
Yes, we can see it.
The presentation slide, right?
Yes, they were, but now they're not.
Okay, just let me know. I'm showing them right now. If they're visible to you, then let me know.
Yes, they are visible.
Okay, thank you so much. Okay, guys. So this is basically the episode 3 of Tech Talks, presented by IEEE 6 and cyber security, NUS cyber security. Okay, so this talk will basically be focused to the introduction of MATLAB, and it will be definitely presented by me. I'm Talha Mehboob. I'm the final year student at doing electrical engineering, definitely from 6, from the batch 2K17. And I'm also working as editor and a WordPress developer at AI Lounge. AI Lounge is a society, or it's basically a company that is aiming to generate at least 5,000 AI developers and researchers by the end of this year. I'm also working as research assistant at Tuckle NUS Development Center, and working as research assistant at Sigma Lab. So basically, the major subjects I'm working on are computer vision and deep learning. So I'm working on a project that focuses the binary segmentation of keratin pulse, that is an anomaly present in the biological slides. So I guess that's good enough for my introduction. Let's start with the introduction of MATLAB. So MATLAB basically stands for the Matrix Laboratory. Okay, so all the things that we will be working in MATLAB will be focused on the arrays and matrices. I'm quite sure that most of the students have FSC background, so they know about the matrices and they know about the arrays because you have already taken the fundamental course of programming in first semester. So the major, you can say, the data structure that we will be using in MATLAB, or we will be looking in MATLAB, will be the arrays. Again, it is an easy access to matrix software. It was built to have an easy access to matrix software, and it was actually built by these two companies, LinPack and IcePack, which focuses on the linear system package and eigen system package, which again involve the computations, uh, mathematical computations and linear algebraic expressions. And we use MATLAB in order to solve these complex algebraic expressions. As moderator mentioned it earlier, that MATLAB is a high performance language, and it integrates the computation in a sense that, as I've already mentioned, that it can solve the algebraic expressions. It could give you the solution of eigenvectors and eigenvalues in a matter of seconds. So it is very powerful in that sense, and the computation in MATLAB is like superb. You can use it for any kind of computations. And visualization, it can show you 2D plots, it can show you 3D plots, it can show you scatter plots. So if you want to show your data set, or if you want to show your mathematical computations or any function, then MATLAB is perfect for you. And then comes the programming. Well, MATLAB actually involves two parts. It's not just a programming language, but it also involves the computation. So it's a powerful calculator, and it's also a programming language. So programming language is something that we actually uses in order to do the computation. So here in this particular tutorial or workshop, we will be focusing, or we will be looking at the both aspects of MATLAB, that is the computation, visualization, and the programming aspects. Again, the last thing is that MATLAB actually has a very sophisticated data structure. It uses very sophisticated data structures, and the debugging tools of MATLAB are again amazing. You can debug your program wherever you are stuck. You see some logical error, you can actually debug your program, and it's very easy in MATLAB as compared to other high-level languages such as C++ or C language, or even Python. You do not really have that much capabilities to debug your program in Python. When you compare to the MATLAB, the debugging tools in MATLAB are very comprehensive, and they are very sophisticated, and it also supports OOP. I'm sure that you haven't yet read about the OOP. These are basically the object-oriented programming, and it's also another kind of programming. You might study in the second semester of electrical engineering, and for the software students, I guess so you will also be learning it in the second semester. So that is the a very precise introduction about the MATLAB. Before starting or before actually giving you a hint of the significance of MATLAB, I want to show you something that for those students who actually have the MATLAB, it's very good. You can use the MATLAB to gain the practical experience for this workshop. But for those students who doesn't really have the MATLAB, they can use the Octave. This Octave is an online based server, kind of, you can say. It provides you the same capabilities that MATLAB provides you. Okay, I can share the link in the chat section, so you can actually open this. So for example, if I'm using this particular Octave online, it's free, so you don't really have to pay anything, as we know that MATLAB actually requires you to pay a lot of dollars. So if those people who doesn't really have MATLAB, they can actually use the Octave to practically run the code and learn for themselves. So I'm going to share the code here, share the link here. So you can use the Octave. I actually shared this earlier so that you can share it. You can open the Octave, and then we can actually start the programming part in the later part of this workshop. Okay, so another thing, you all are here because you want to learn MATLAB. Why do you want to learn MATLAB? Obviously, because you know that, or you don't really know that that why are we using this MATLAB, or why are we teaching this MATLAB? Because MATLAB is such a programming language, or such a platform which is used in so many of the fields. For example, you can see that its applications could be seen in digital programming, digital signal processing, embedded system, control systems, wireless communications, which you can also say as the 5G of the new era, and image processing, computer vision, robotics, and or the which we give the special treatment to deep learning. But the favorite of everyone, that is deep learning. So MATLAB could be used in any of these given fields, and that is the reason that MATLAB is such a powerful language, and why we as IEEE Sikhs are presenting you, or we are talking on this particular subject, that is MATLAB. So for that reason, the basic structure of MATLAB is matrix, as I mentioned earlier. So what is a matrix? Matrix is nothing but when you basically combine the data in a particular format, then it becomes a matrix. For example, I'm writing here, I'm building here a simple matrix which has 9 elements, and its order is 3 by 3. I guess your speakers or sorry, your microphones are off, so I'm the only one who is going to talk here. So okay, so I have basically written a matrix here, a matrix A, which has the order 3 by 3, and it has some data entries in it. So how is it applicable, or how will we be using this particular matrix in order to gain data from data, and using this concept in different fields, in different dimensions? For example, how will we use this in digital signal processing? How will we use it in the computer vision or the image processing? So the thing is, let's start with the digital signal processing. Let's say you have a transmitter, okay, and here you have a receiver, and someone is actually sending the data here in bits and packages. So the data is sent here, and here the receiver is actually getting the data, or is receiving the data. So what happens is it here is that the transmitter is actually sending data in a particular format, and that format could actually be the matrix. And here at the receiver end, the receiver is actually receiving the data in some particular format or the data structure, and that data structure again is the matrix. So one can say that the transmitter sent at, let's say, t1 is equals to 1 second. So at the initial time, the transmitter sent some data, and we denote it as the array number 1 of this matrix. So transmitter sent 1, 2, and 3 as some data package or bits, and at the receiver end we received 1, 2, and 3. So what we have here is these particular entries are the data entries, and we have placed these data entries in this particular matrix. Again, at t is equals to, let's say, at some other time, the transmitter again sent some data. So at t is equals to 2 seconds, the transmitter sent some data that was 4, 5, 6, and the receiver received the data as 4, 5, 6. So we again, you can say, combined this data or organized this data as this particular matrix, or the second row of this particular matrix. So I'm sure that you are getting the idea that how are we using this data analogy into the digital signal processing, and how are we using matrices into the digital signal processing domain. So if we let's say we got the data, we made the matrix, but the problem is that you won't be getting a data in these small entries. You won't be getting just 3 entries of data. You will be getting like millions of entries. Like when it comes to millions, that the size of this particular matrix will be, let's say, 1 million by 1 million. Okay, so when you have to do computations on this matrix of order 1 million by 1 million, you need some specialized software, and that specialized software is actually MATLAB. So I'm sure that I actually able to communicate with you the basic phenomena, that why are we using MATLAB here. So uh, again, just as I showed you, we used it, the matrices or the MATLAB in the field of the digital signal processing. Similarly, it could also be used in embedded systems. In embedded systems, you are actually working with the microcontrollers and the microprocessors in order to do some particular task. So you will be using the software and the hardware, collaborating both in order to do some specific tasks, right? And in order to do that, you need some specialized software, and that software is basically the MATLAB. Similarly, in control systems, if you the electrical engineering students, they will learn about the control systems, and in that particular course, you will learn about the state space representation. Okay, that is again the representation of some variables that are stored in the format of matrices. So in order to solve the matrices, again, you need the MATLAB. You can do the computations on other softwares. For example, I guess the computation of this MATLAB is Mathematica. But again, MATLAB is more universal, and it's faster than the Mathematica, and it's better than the other languages. Okay, and again, the control systems is very much essential subject if you actually want to get into the industry, and also for those who want to do the research. So it's uh, one of the most major topics or the major subjects that you will be learning in electrical engineering. Then again comes the wireless communication. We all know about the 5G in today's era. Even in fact now 6G or 7G, I don't even know how many Gs are there. But people are working on 5G, people are working on 6G, and in that again, people are working with the data, people are working with the bits packages, and that bits or packages are actually communicated as matrices. Then comes the application of MATLAB in image processing and computer vision. I guess this is the most basic or simple example, because we all know that what is the image? An image is basically something that has small pixels in it. Okay, and when these small pixels are actually united together in a uniform manner, they form a complete picture. Okay, and these uniform pixels, when presented as arrays, they are nothing but they are matrices. I actually don't have an example here where I could actually show you the an image as and presented as an array. So here, what happens is, uh, you all know that if we mix some colors, then a new color appears. For example, the elementary colors are red, green, and blue. So if I mix the different intensities of red, green, and blue, they will actually form me different colors. So for example, I say that let's start with the black and white image. So if I have an image, then the zero intensity or the zero value in the matrix, let's say here I put a 0, then the zero entry would suggest that this is a black pixel. Okay, the pixel is actually showing the black value, right? And if I'm writing 255, because it's a 8-bit system, a byte, you might not know about it, and you don't really want to know about it right now. But if it's representing the number 255, then it represents a white pixel. So the images are basically these images. When uniform together, when organized together, they form a particular data structure, and that data structure is known as the image. Or the pixels, you also say that the pixels form the image. So these pixels are again in the form of matrices, and if you want to deal with the matrices, you can use the MATLAB. Then comes the robotics again. If you want to store data, if you want to share data, you can use the MATLAB. And again, the deep learning. So many students here want to learn about deep learning. So matrices again are the basic structures for the deep learning, where you will be storing the data in the form of so you will be storing the data in the form of matrices, and those could be computed by using the MATLAB. I don't know if I have enough time to show you example here. Let's say if we could actually find time, I could show you the example at the end. Uh, Again, the use in the industry. As you all know, the MATLAB is a paid software, so definitely whoever has made the software knows the worth of this particular software. So most of the major industries are using the MATLAB for the computing purposes, for visualization purposes, and in order to do the programming. So MATLAB is basically used in the automotive industry, biological sciences, communications. As I have already mentioned in the previous slides, how we were using the MATLAB in communication. It is used in electronics, financial services. In financial services, you can actually store the data and store it as arrays or matrices, and then you can compute or you can do the computations on those financial data set using the MATLAB. Then comes the industrial automation and machinery. Again, the data thing, you can use the MATLAB. Then the medical service devices and the software and internet. I'm sure that since I've already explained the major fields, so the industries come under the heading of those major fields. So this was the significance of MATLAB, that why are we teaching you, or why are we talking about MATLAB in today's Tech Talks and today's session. Okay. Again, this was the introduction. Let's start with the MATLAB. So those people who actually have MATLAB, here we are. Those people who actually have MATLAB can see there are different windows here in MATLAB. Okay. So the first window, or the major thing that we will be working on, is here is the command window. So here we provide some commands to the MATLAB, and it processes those commands and returns the solution. For example, the simplest example one could actually think of: 1 plus 2, let's say, or 1 plus 1. What would be the answer? 2. So what MATLAB does is it takes the inputs, it took it as a command, it processes it and returns the answer. So this is the simplest example one can actually use, or one could actually do using the MATLAB. So we have the command window. Let me clear this. Okay. So we have the command window here. Then again, at the end, we will be learning about what exactly the script or the programming, how can we actually use the MATLAB as a programming language. And then we will be learning about the M scripts and the M functions. So here we have the scripts where we can write the code, and then we can actually run the code at the end. But in command window, as soon as you have written the code and you press enter, it will give you the answer. You cannot store the variables for long, and you cannot do the multiple, you can say, computations in here in the command window. Okay, again, the other thing is the workplace. The workplace denotes the all the variables that you have made, or you built during your program. So for example, in this particular example, where I did the sum of two static values, I didn't use any variable. So what MATLAB does is it computes the input and then it returns the answer in some uh, in a variable that is actually known as the answer. So I'm sure that I could actually show you the it's visible to you because it's not that much I don't know how to zoom this thing. It's not getting zoomed here. So I can dictate it. K 1 plus 2 is basically returning me the answer. The variable here is the ans. The answer is the variable, and it's returning me the value 3. So MATLAB uses a predefined variable in order to store the value of the answer. And here in the workspace, you can actually see the variable and its value, the name of the variable, and the value assigned to that particular variable. I'm sure that you know about the variables and the values that are basically assigned to the variables, because all the students here have already taken or already taking the fundamental course of programming. So you should know what a variable actually is. Then again, the last thing here is the current folder or the current directory. Here I have these multiple files that were actually used by me in order to build some labs or whatever. So here you can actually see the main directory or parent directory, the current folder where your files are actually getting stored, and the files that you have already worked on. And the last thing is the current directory thing. It's important because whenever you will be working with the images or external files, you will be using the or you should know about the directory where the program is getting executed. So here the current directory is E folder, MATLAB folder, R2017A, and the bin. So this is the current or the major directory where the files are getting executed. So you should know about the directory, because you could the MATLAB could present you some errors when the directory is changed, or there is some error or malfunction in the directory. So you should know about the directories too. So this was pretty much all you should know about the MATLAB when you are getting started. Again, if you want to, we won't be using this run command or comment or uncomment section or whatever these commands written here in the initial or the first part of this workshop, but we will be using this in the later part of the workshop when we will be working on the script files. Okay, so this was it for the introduction of MATLAB.
Okay, sir, we have a question here.
Just give me a second. Sure.
One of the students asked why MATLAB is better than Mathematica.
Okay, I cannot answer exactly on that because I don't exactly know the difference between these two. But again, the community of MATLAB is so wide that if I write a single, if I want to say some help from the internet, the MATLAB community is huge. People have already worked on so many things, and they have actually contributed to the community, and they have uploaded their solutions. So you can find the help very easily in the MATLAB. Again, the other thing is the debugging tool that is very advanced in MATLAB. I don't actually know about the Mathematica, how does the debugging is done in that particular software, but universally people are using MATLAB because MATLAB is thought to be better, and its community is better, and the speed at which the operations are getting done is faster than the Mathematica. But I'm sorry that I don't really know the exact answer of this. I haven't done the maths, or I haven't compared them both in terms of computations, but generally the MATLAB is thought to be better and is widely used, maybe due to the variety the variety of operations it offers. Excuse me. Okay, hope I could answer your question. Okay, so Jupyter Notebook is actually that is used for the Python language and other languages, but for MATLAB we use the MATLAB or Octave only. Okay, let me get back to where was I? Okay. Again, we have seen that MATLAB could actually be used as a calculator. So if you want to do the simple calculations, you can actually use the MATLAB. And it can not only be used for the simple calculations, but it can also be used to do the complex or lengthier mathematical computations. Okay, so for example, here some examples are given, and we can actually try them. Since I guess we have some time, so the whole purpose of this workshop is to get hands-on experience of the MATLAB coding. So I would suggest that those who have the MATLAB, they may open the MATLAB and try to follow me. We will be running some code here, and we'll be getting our hands dirtier. And then those who doesn't really have the MATLAB, they can use the Octave. So for Octave users, I can show you the simple command. Okay, so again, it's that simple. It's exactly do things as MATLAB does. So when I did 1 + 2, it gave me an answer. It returned me the solution in the variable answer, just as the MATLAB did. Okay, so the command window of the MATLAB and Octave are actually similar. So you can use the MATLAB. You can use the Octave. Uh, okay, for the first example, simply go to the command window, and then you have to write the statement or the command. I don't know exactly what the command was. Okay, so what it does is it has the precedence. So it does this operation first, multiply the two variables together, and then adds the third one in it, and thus it will give me the answer 1 + 2 × 3, that is 7. Again, the other example could be we can use the variables. Okay, so for those people who doesn't know what a variable is something that is built in the memory, and there you can actually store the value of something. Okay, something could be an expression or some static value. For example, I define a variable x, and I want to store a value of this particular expression, that is 1 + 2 × 3. So I'm actually assigning the value of this particular expression to the variable x. So when I click or when I enter this, it has assigned the value 1 + 2 × 3, that is actually 7, into the variable x, and it gives me the answer x as the 7. So the difference here is that in previous example, we just ran the command as we do in the simple calculator. We just write the numbers, we put the operations in it, and that's it. We got the answer. But in when we use the variable, we are actually defining our own particular variable where we want to collect the answer. Okay, so you can see that both these variables, answer and the variable x, are mentioned here, and they are two different variables. Although the value assigned to them is same, but these two variables are different from each other. Okay, then the third example could be that we can actually multiply something with this variable that we just made. So here, let's say I want a different value to x, and that gives me the solution. Since the value of x was 7, and 7 into 10 is 70, so 7 into 20 is 140. So now one thing here is that I didn't assign the value of this particular expression to some variable. That is the reason that MATLAB has stored or returned the value of this expression into the default variable, that was the answer. So now the value of answer has already been rewritten or overwritten, and the value now is 140 rather than the 7, which was previously which we got previously doing this particular expression 1 + 2 × 3. Okay, this was a basic example where we actually learned that MATLAB could also be used as a simple calculator, and it could also be used as a complex calculator. It can do the complex computations, but I don't think we should be spending much of time doing complex computations here. You can do it later when you're free, when you get some time. Okay. So these are the major operations that we actually do in the MATLAB. That is the addition. We all know what addition is. Subtraction, Multiplication, the symbol of multiplication is a bit different. We use x as the multiplication symbol for the in the mathematical computations, but here in MATLAB we use the steric symbol. Again, for the division, it's rather a similar kind of expression. We know about this division expression or symbol, and again it will return us the division results in the answer variable. So these were some basic operations that we can actually apply on the variables or the static values, or some even some expressions. Okay, I've already mentioned the I've already used a variable, but again I included a separate slide for on the MATLAB variable. So MATLAB variables are actually created using the assignment operator. So what exactly is an assignment operator? I'm sure that you have learned the um, programming, so you can actually tell me that what is the difference, what could be the difference between these two things. Here I have used two equal signs, and here I have used a single equal sign. Okay, so whenever we use two equal signs in programming, wherever we use two equal signs in programming, for example in C++, in C, or even in Python or some other languages, this operator is equality operator. Okay, it is an equality operator. So if we have two values, let's say 1 equals 2, so this will see that on the left side the static value is, or the variable value is 1, and on the right side the variable value is 2, and both of these are not equal. So what it does is it sees, it looks if both the values on the right hand side and the left hand side are equal, and if those values are equal it returns true. But as in this case these two values are not equal, it will return us the false. Okay, it could also be represented as 0. Okay, but the assignment operator is something uh, in which on the left side this could not be a static variable, this could not be a something that is static. Okay, you always need a variable to assign the value of something. That something could be some expression on the right hand side, this something could be an expression, this something could be a variable, this something could be a static value, and you assign it to some variable, let's say x. Okay, so this is how we assign the